Hi, welcome to my video on thermodynamics part 2. So in the previous video I explained you about what is a system, what is a surrounding, and what is meant by a wall and a boundary. Okay, in this video I will be explaining to you about the work or the work done in the thermodynamics context. Okay, so now let us take the system that I have explained in the previous video. A cylinder fitted with a frictionless piston containing a gas at a particular volume. Say we can say the volume of the gas is represented by Pi, and the external pressure that will be acting on the piston from outside will be the P external pressure, and the pressure of the gas inside will be called as the internal pressure Pi. So now this is the internal pressure, that is the pressure of the gas present inside the cylinder, and this will be the external pressure. That external pressure is atmospheric pressure acting on the piston from outside. When these two pressures are equal, that is when the P external atmospheric pressure equals the internal pressure of the gas, then the piston stays in the same position, it does not move. Now when we try to heat this cylinder or the gas, when we supply heat, say for example if you supply Q joules of heat, some amount Q joules of heat, then what will happen? The gas will expand. So let me draw this expanded position like so. You have the cylinder again here like this. Now when the gas expands, the piston goes up, and the gas inside the cylinder is the volume of the gas increases. To fill up the entire area due to the heat supply. Now we can see that this will be the final volume of the gas. Inside the cylinder. Now the pressure of the internal pressure is pushing the piston up against the external pressure. So at a position when the internal pressure and external pressure again becomes equal, then the piston stops. Now you can see that this is the expanded position. Now if you look at the change in the volume, we represent it as delta V, change in the volume, Vf minus Vi. So always we measure the change in the volume as final minus initial in the case of a gas, or if it is a chemical reaction we represent it as products minus reactants. That is what we call it as the change, product minus reactants. Okay, now in this case the gas has expanded, that is the gas is the system that we are talking about. In this context. Since the gas expands, here we say that the work is done by the system. So this is what we call it as a work. So now the gas has expanded, that expansion work is done by the gas. Okay, now suppose instead of heating the cylinder, suppose if I compress the piston. So again you have the cylinder. Suppose if I compress the piston, that is if I push the piston inside the cylinder, I am increasing the external pressure from the outside. So you have the P external pressure acting from outside like this, which is increased, and then you have the internal pressure of the gas against this. So when we increase the external pressure, then the piston goes down. So here, and therefore the gas is compressed. So that means, as I told you, the gas is what we refer to as the system. Therefore, here work is done on the system. Work is done on the system. So these two definitions you have to be familiar with. Work is done by the system and work is done on the system. So in this case, work is done by the system when there is an expansion. So we can say that work is done by the system includes expansion of gas. So here work is done on the system includes compression of gas. Okay. Now if we measure the volume here again, you can see that this is the volume, final volume. So as before, delta V, change in the volume, is given by final minus initial. Therefore final will be Vf minus Vi. So as we can see from this compression, the final volume is smaller than the initial volume, because here the volume is less and the initial volume that we see is more. So it is greater than this. Initial volume is greater than the final volume. Therefore this algebraic sum will equals Vf is less and Vi is more. So this is going to be a negative value. So delta V is equal to negative is negative. Okay. Now in this case, if you look at this, in this work is done by the system, we have the final volume is greater than the initial volume, as you can see. So this volume is greater, that is Vf is greater than Vi. Vf is greater than Vi. Therefore this value, delta V value, is going to be Vf is greater, Vi is smaller. So this is going to be a positive value. So these are the two statements that you need to know regarding the work done in the case of a thermodynamic system. So thanks for watching. Let's see in the next video the sign conventions of the work done in the case of thermodynamics.